61.
A modern supermarket is a thing of wonder. Even if it's snowing outside and summer is a distant memory, you can buy strawberries, peaches, or grapes. If you want root vegetables in the middle of a heat wave, you can have them. Expat Americans can have their Oreo cookies, while homesick New Zealanders can console themselves with wine and kiwi fruit. Within days of being picked off the vines, the fruit is in your trolley, tasting of spring as the leaves are falling outside. It's all great until you start contemplating the vast mileage sitting in your shopping basket. Those kiwi fruits have traveled nearly 20,000 kilometers, or 12,000 miles. They've flown in a plane and traveled by road. By the time they reach the supermarket, they're responsible for 5 times their own weight in greenhouse gases being pumped into the atmosphere. Increasingly, our food is coming from further and further away, and we're becoming more and more dependent on the fuel it takes to get them to us.
62.
This dependence was illustrated very clearly during the September 2000 fuel price protests in Britain. Inspired by similar actions in France, a group of farmers and lorry drivers decided to blockade the Stanlow oil refinery in Cheshire. The protest quickly snowballed, and petrol tankers were unable to leave refineries. Panic buying saw more than 90% of petrol stations run dry. And with supplies unable to get through, supermarket shelves quickly emptied. It's estimated that food now accounts for as much as 40% of all UK road freight, and the international food trade is increasing faster than the world's population and food production. In other words, food is moving around more than ever, and the environmental impact could be huge. Despite the UK's cool climate being perfectly suited for growing apples, nearly 3/4 of the apples eaten in the UK are imported, and more than 60% of Britain's apple orchards have been destroyed in the past 30 years. We're now putting more energy into transporting some crops than we get out of eating them. For every calorie of lettuce imported to the UK from America's west coast, 127 calories of fuel are used. Put it another way, flying over a kilogram of Californian lettuce uses enough energy to keep a 100-watt light bulb glowing for 8 days.
63.
One of the most popular ways to demonstrate this year's severe U.S. winter appeared to be tossing out a glass of boiling water and watching it freeze instantly in mid-air. Of course, the reason the fun experiment impressed viewers is because nobody expects boiling water to turn to ice that quickly. It turns out that contrary to intuitive thinking, it actually freezes faster than cold water. Why? That's a mystery still waiting to be solved. While this phenomenon has been observed for thousands of years, it was brought to the world's attention in 1963 by Tanzanian high school student Erasto Mpemba. It all began when the young boy was learning to make ice cream in cooking class. After dissolving the sugar in boiling milk, the students were instructed to allow the mixture to cool down before putting it in the ice cream churner. Too impatient to wait, Mpemba put his mixture in while it was still hot. To his and everyone's surprise, his ice cream was the first to freeze. His explanation appeared so unbelievable that even his teacher thought Mpemba must be mistaken.
64.
Convinced that he had discovered something, Mpemba told a visiting physics professor about his accidental experiment. Like his teacher, the professor was a little doubtful, but invited him to test the theory. The two began by filling 100 milliliter beakers with 70 milliliter samples of water of varying temperatures and placing them in the icebox of a normal refrigerator. What they noticed was that it took longer for the water to freeze when the temperature was at 25 degrees Celsius than when it was at a much hotter 90 degrees Celsius. Since then, the phenomenon has been known as the Mpemba effect. However, while the two were able to demonstrate it, neither could find a scientific explanation for why it occurred. Over the years, researchers have come up with several theories. The theory that most believe is fairly straightforward. It is a known fact that hot water evaporates faster than cold. Hence, when boiling water is tossed into cold air, some of it turns into steam and disappears, leaving behind less to turn to ice. Sounds plausible, right? In fact, Mpemba had thought of this possibility and even tested it. Unfortunately, he found no difference in the volumes of the ice formed at different temperatures.
65.
A more recent scientific study conducted by Zai Zhang at the Nanyang Technological University in Singapore attributes the phenomenon to the chemistry between the hydrogen and oxygen molecules that make up water. The researcher believes that as the temperature rises, it provides the molecules with a lot of pent-up energy. When this water is tossed into a cold environment, the energy jumps out in a way similar to how a highly compressed spring would when released. This results in the hot water cooling down much more rapidly than cold water, which does not contain as much energy. While all these theories are plausible and explain the phenomenon under certain conditions, none seems to provide a satisfactory universal solution to this strange physical property that has confused scientists since Aristotle observed it in 380 BCE.
66.
Even with the hard work and caring of many dedicated teachers and concerned parents, the U.S. continues to have a reading problem. According to the National Center for Educational Information, 38% of fourth-grade students cannot read and understand a short paragraph of the type found in a simple children's book. Results from a 1998 study showed that 60% of U.S. teenagers could comprehend specific facts, but fewer than 5% could elaborate on the meanings of the material read. No wonder many parents are discouraged, but they needn't be. By doing simple things like reading to their child, sharing their thinking about what they read, and telling their child stories, they can help develop the foundation needed for children to become good readers and learn that reading is not a chore, but a lifetime adventure.
67.
Good readers follow a number of key strategies, whether they're reading a magazine or a textbook. Firstly, they create a wide range of mental and visual images as they read, to feel involved with what they are reading. Then, they use their background and relevant prior knowledge before, during, and after reading to enhance their understanding of what they are reading. They also make and ask questions before, during, and after reading to clarify meaning, make predictions, and focus their attention on what's important. Good readers infer and determine the most important ideas or themes, and distinguish between these and unimportant information. Next, they track their thinking while reading to get the overall meaning. Finally, if they have trouble understanding specific words, phrases, or longer passages, they use a wide range of problem-solving strategies, including skipping ahead, rereading, asking questions, using a dictionary, and reading the passage aloud to fix up their understanding. Reading is fundamental to success in life. It's that simple. Reading opens the door to virtually all other learning. You have to be able to read to learn mathematics, science, history, engineering, mechanics, political science, not to mention to surf the web or figure out how to operate that new DVD player. Basically, you have to be able to read to succeed.
68.
How would you feel if a robot looked after your child? Worried? Anxious? What if that robot was as intelligent as yourself, if not more so, and was able to react to every problem and whim without ever tiring or wanting to scream? For those studying and working in artificial intelligence, AI, creating this kind of situation could so easily become a reality. AI is embedded in many educational applications, explains Janet Reed, a professor in child-computer interaction at the University of Central Lancashire, pointing to new gesture recognition and interpretation technologies. Brain-computer interfaces are detecting mood and emotion, and in the near future, robotic and virtual systems might be able to partially take on the care of children.
69.
AI is one of the most exciting fields of technological study, giving computers the ability to think, learn, and adapt when faced with a host of data. But it is not a technology of the future. It is all around us today, pervading our everyday lives and allowing us to take advantage of image and voice recognition software, intelligent web searching, and medical advances. The latter made possible thanks to robot scientists formulating hypotheses and interpreting data. Modern video games use AI to generate intelligent behavior in non-player characters. NASA's Mars rover was designed to make its own decisions, stopping and analyzing only the rocks it felt would be useful. And more is to come, with driverless cars and intelligent home systems on their way. As a result, many universities have been promoting AI courses and modules for both undergraduate and postgraduate students. Each of them requires a solid background in computing, maths, and physics, and explores knowledge representation, planning, and learning. Studying AI is perfect for students who can solve problems in abstract ways and devise new angles, says Dr. Richard Watson, senior lecturer in electronics and computer science at the University of Southampton. But AI is also about learning techniques of advanced computer science. So students should have a broad education in computer science before they tackle it. For that reason, very few undergraduate degrees will concentrate entirely on AI. Instead, it tends to be offered as modules within an overall computer science degree.
70.
Neglect of the mind-body link by technological medicine is actually a brief aberration when viewed against the whole history of the healing art. In traditional tribal medicine and in Western practice from its beginning in the work of Hippocrates, the need to operate through the patient's mind has always been recognized. Until the 19th century, medical writers rarely failed to note the influence of grief, despair, or discouragement on the onset and outcome of illness, nor did they ignore the healing effects of faith, confidence, and peace of mind. Contentment used to be considered a prerequisite for health. The modern medicine man has gained so much power over certain diseases through drugs, however, that he has forgotten about the potential strength within the patient. One elderly physician friend recently told me of reading the diary of his uncle, also a doctor. In the early years, the diarist always recorded what happened to the individual or the community prior to an illness or epidemic. But as medicine became more technological, this part of the history grew less and less important to him, and finally was omitted altogether. Awareness of the mind's powers was lost as medicine cast out all soft data, the information that's not easily quantified or scientific.